This is a video about direct heating of water, and I'm not totally in favor of that, but I was watching a video and the guy was doing a totally autonomous system. That means it didn't connect into his house or anything like that for power. And to operate the solid state relay, he was going to use a 100 watt 12 volt panel just to provide power to this. And and that would work because you're only heating during the day when the sun is up. This is only, I measured this one. If you look here, it's on. It's 6.8 milliamps. And, well, when the sun comes up, you're going to have at least that much to power to turn on your supply. And you can't just run this off the solar panels directly because in direct connect, the voltage from those solar panels can go down to near zero and not be enough to power this. So I was thinking, like, well, I ought to be able to come up with something a little bit better. And my idea was to use a little wall wart power supply. I hate to say it, but everyone has a few of these lying around from an old cell phone or something. This is 5 volts at 0.7 amps. And I have it hooked into my system. And my panels are only about 60 volts. And that's enough to power these. And so the wire comes in right over here. This is the positive. And of course, everyone has some old lithium batteries around. If you've thrown them all out, you can always go down to Home Depot or Lowe's and grab down into their battery recycling and probably come up with an old laptop battery or something like that. And you can pull one of these cells out, and you'll probably at least find one good one in the pack. Generally, one or two go bad, and that's enough to make whatever product that was using them useless. So these, the top voltage you want on these is about 4.2 volts, and your 5 volt charger is about 5.2, so there's a voltage between those. You don't want to over voltage the battery. So I have this simple circuit here. You take your 5 volts, and immediately with one diode, any silicon diode, you can pull out of something, and you'll get about a 0.7 volt drop. At low currents, it could be 0.62, 0.58, but you'll get a voltage drop. And then you could put, my idea was put 2 diodes in series. And so the maximum voltage drop you'll have is 1.4 volts. So you'll always be keeping your lithium ion battery at about at least 3.6 volts. And probably closer to about 3.8, 3.9. And you can go forever at that. That's a nice value. And I put a little resistor across one of the diodes because that allows it to do a little more charging. As you can see, what I've measured here, 0.375, it's about 14 milliamps that's going into the battery and the solid state relay. The solid state relay takes 7 milliamps. I've tested some of them. Some of them are like 10 milliamps. But they're all going to be from, probably the 5 or 6 milliamps up to about 12 milliamps. And they're 3 to 32 volts. So a 4.2 volt or 3.8 volt lithium battery is more than enough to power everything. I go in with 14 milliamps to provide a little bit extra charge to the battery. So at night, this will be drawing 7 milliamps from the battery. and during the day we throw in an additional 7 milliamps. Plus, if it's dropped down a bunch, it'll never get below a value that is not good for the battery. So this is a pretty simple system, and this is what they call an upper thermostat, and the upper thermostat has two thermal over temperature things. So yeah, I have a loop here, and that's because I hang this on the wall to keep it somewhere. But this is one switch, and this is another switch, and then there's either an internal shorting bar, which this one has, or you'll actually see another screw here with a wire going over to another contact here, and that goes over to here. You set your temperature. But on the extra one here, or maybe you got two of them, always wire a heater through those for safety. You don't want to break those contacts often with high voltage, but they'll do it a couple times, and two of them in series would be more than adequate to turn off your water heater should something go terribly wrong. But that's the little tip for today. I'm going to be testing this. This is a 60 amp solid state relay. We'll see what this goes down to in voltage. Many of these have just too high of what they call a saturation voltage. When it's fully turned on, these can be up to 2 volts. So 2 volts times 10 or 20 amps is a lot of wattage. You need a lot of heat sink. So I'm hoping this 60 amp is better than my last 40 amp. So we'll be testing that soon.